Hello and welcome to Data Vigo channel. In this video, I'm going to explain what natural language processing is about and explain it to a non-technical person. So if you have no idea what that is and you're curious about it, or you have just kickstarted your data science training, this video could be a good start. I will explain how it works and introduce the common libraries in Python and the language models used in a typical NLP project. At the end, if you're learning data science, I will give you some project ideas for your portfolio. So let's get to the point. Natural language processing, or NLP, is a field of artificial intelligence that gives the computer the ability to read, understand, and derive meanings from human languages. In other words, we want to train the computer to understand the human language. So let's say this simple example. If I ask you to find the analogy for these words, then how would you do it? So if I tell you that the relationship between Paris to France is similar to the relationship between London to, and then I'll ask you, to fill out the blank, then you're going to say England, obviously. So Paris to France is similar to London to England. Or Queen is to woman as king is to what? Then obviously you're gonna say man. So you were able actually to give answers very quickly. But the question is that how do we know this as humans? Well, since our childhood, we have learned that Paris is the capital of France and London is the capital of England. Or the word queen must refer to a woman and the word king must refer to a man, because we have seen numerous examples in our life that the word queen should be about a woman, not a man. And that's why we instantly could answer these questions and it was very easy for us. So the question is that can we train a computer to learn in a similar way, similar to the humans or not? In other words, we want the computer to correctly classify queen as a woman and Paris in relation to France. So if we give a lot of examples to the computer, and in other words, we train it similar to humans, and we have been trained before like this because we have seen in a textbook, in pictures, in news, in many occasions that the queen should be a woman and the king should be a man, then we can also expect the computer to give us the correct answers. And this is exactly what we mean by training the computer. This simple example, in fact, is one of the applications of the NLP. It is simply about finding similar keywords. So we all have experienced this in our daily life. When you buy or search for a product on Amazon website, for example, you're putting a keyword. You will then see that the Amazon offers you similar products based on your search history and based on the keyword that you have put into the search box. So think about the keyword laptop. So you as a human, can you identify the similar keywords that come to your mind? Think about Netflix or some other similar on-demand services. They also suggest movies to you based on what you liked, but how do they do that? Each movie actually is defined by a set of keywords, not just only by one keyword. And Netflix actually makes suggestions based on these similar keywords. So here, if you take the example of Money Heist movie, I don't know if you have watched it or not, but if you want to define it by some keywords, well, those of you who have watched this movie, should be able to do so. What keywords you would actually allocate to this movie? Probably you're going to say Spanish, it's an international movie, it's about thriller, action, and many more. So if you like this movie, Netflix actually is going to offer you something similar based on these keywords. So I was wondering if you had this question in your mind, that how these keywords are represented in the mind of a computer. Because for us as the humans, they're nothing but a bunch of strings, or they're just text. So how are these words or the texts are perceived by the computer? Well, the answer lies in something called word embedding. Word embedding means representing the words as vectors. So for computer, each word in a sentence is considered as a vector. So the word is Spanish, international, man, woman, king, Queen, London, everything in the text, they're nothing but a vector. So you may again, ask this question that then how these words are converted into the vector. In order to convert these words into vectors, there are many language models developed and they can be used with Python. You can see examples of some of them here that are word2vec, glove, fasttext, BERT, and Gensim. You need to install the packages for any of these language models and simply import the libraries, which is not the scope of this video. Then you can convert words into vectors using any of these models. In fact, you can also create a vector or matrix of words yourself, such as the example in here, and this is based on two simple sentences. You can see that how it works. To give you a better clue, if we visualize two vectors in a 2D dimension, such as this one, we can measure the similarity based on a cosine similarity or cosine distance. So two vectors or two words that are very similar to each other will have a close to zero angle, and the cosine of 0 is equal to 1. So imagine if we have lots of words plotted as vectors in a space, then we will get the visualization like this one. And this is how we can actually do the clustering technique using t-SNE, which will also be explained in the future videos. So let's talk briefly about the language models that we have mentioned. The word2vec model is actually based on a paper written by Thomas Mikolov at Google in 2013. In fact, the idea of the relationship between the king and man and the woman and the queen is actually coming from this paper. As part of the word2vec model, there are two other models that could be applied as well. One of them is called continuous bag of word, or CBOW model, and the other is called the continuous skipgram model. The first one, CBOW, learns the embedding or vector by predicting the current word based on its context. The second one, the continuous skipgram model, learns by predicting the surrounding words given a current word. So the auto-completion sentence, for example, that you find in some services such as email writing, in fact is following a similar principle. Another model that is used in NLP is called GLOVE, which stands for Global Vectors for Word Representation. This is an extension to word2vec model that we discussed previously, and it was developed by Stanford University. And this model has actually improved the efficiency of the learning vectors. The Euclidean distance, or the cosine similarity between the two words represented by the vectors, provides an effective method for measuring the linguistic or semantic similarity of the corresponding words. There are also two more popular models. One of them is called fasttext, which was created by the Facebook AI team in 2015 for learning of word embeddings and text classification. Another one is called BERT, and this was actually developed by Google in 2018. And it's basically about reading the text input and then producing the prediction out of it. And the final one, which is called Gensim, which is, again, works in the similar principle, and it creates vectors from the words. So this was a very brief overview of the natural language processing for those who do not have any experience on it. There are many projects you could do in relation to the NLP that I have listed some examples in here, but obviously feel free to suggest yours in the comments. For example, you can do keyword similarity project. So there are some data sets on the companies identified by the keywords on Kaggle. And what you can do is to develop a model that can group companies based on their keyword similarity. In fact, this is a highly applicable technique in the market intelligence softwares and the B2B services. Sentiment analysis is also a popular example of an NLP project. You can train a model that can detect the sentiment of a news and use it in the stock trading. In fact, a lot of people are doing this nowadays. And much more examples such as face news detection, spam detection, because they all have a kind of pattern in their text, building a recommendation system, and document similarity for plagiarism purposes. And we will cover some of these in the future videos. So I hope you enjoyed watching this video and keep watching Data Vegan channel. If you like our videos, please do not forget to like them and post your suggestions in the comment box.